Welcome back students. This is part 2 of chapter 2 polynomials. In this video we will learn the concept which will be used for solving the sums of exercise 2.2. Now we will learn the relationship between zeros and coefficients. Zeros. Now we have learnt about zeros in the previous video. You already understood the meaning of zeros. Like I will explain you once again. For a certain value of variable for which the polynomial becomes 0, that is the 0 of the polynomial. In the first example you can see x square minus x, and if you are putting x equals to 1, you are getting polynomial equals to 0 on solving. So in this 1 is the 0 of the polynomial. And you can see the other example also, y cube plus 1, and on putting y equals to minus 1, we are getting polynomial equals to 0. So minus 1 is a 0 in this case. Now you have clear idea about the 0 of the polynomial. 0, root and solution are all same. Now coming towards coefficient. Coefficient are the numbers which are written with the variables. For example, if we have polynomial 6x cube minus 3x. So in this polynomial, 6 is the coefficient of x cube and minus 3 is the coefficient of x. We will take one more example, 2x cube minus 4x square plus 1. Here coefficient of x cube is 2 and coefficient of x square is minus 4. Now you know what is the meaning of zeros and coefficients. So let's understand the relationship between them. If we take a quadratic equation ax square plus bx plus c, where a, b and c are some real numbers. So assume alpha and beta are the zeros of that polynomial. In that case, so your sum of zeros, that is alpha plus beta, will be equals to minus b by a. And if you take the product of zeros, that is alpha into beta, it will be c upon a. C is your constant term and a is coefficient of x square. Let's have a better understanding in the example. See, we have a quadratic equation 2x square minus 4x plus 1, where your a is 2, b is minus 4 and c is 1. So in that case, your sum of zeros, that is alpha plus beta, will be equals to minus of minus 4 by 2, and product of alpha beta, that is product of zeros, will be equals to c upon a, that is 1 by 2. Now we will understand it in a better way while solving the given problems. Now if you have been given a cubic polynomial, this I am giving you only for understanding. Exercise 2.2 will only be based on quadratic polynomial, not cubic. So just for understanding, you can see, if you have got a cubic polynomial ax cube plus bx square plus cx plus d, then your sum of zeros will be equals to minus b upon a. B is coefficient of x square and a is coefficient of x cube. Product of sum of zeros, that is alpha into beta plus beta into gamma plus gamma into alpha, will be equal to c upon a. C is the coefficient of x and a again is the coefficient of x cube. Product of zeros, that is alpha into beta into gamma, will be equals to constant term upon coefficient of x cube, that is d minus d upon a. So this is for cubic polynomial, since cubic polynomial will have 3 zeros. Now let's try to solve problems of exercise 2.2. Here you can see in question number 1. Please find the zeros of the quadratic polynomials and verify the relationship between zeros and coefficients. So first you have to find the zeros. After finding zero, then you have to verify the relationship also. So the total questions are 6. I will do 3 out of 6 questions and the remaining you can do yourself. And if you have any doubts, you can always post in the comment section. Now I am doing second part of first sum. Here you have to find the zeros and then you have to verify the relationship between zeros and coefficients. So first we'll see they have given us 4s square minus 4s plus 1. So this is quadratic equation, that means it will have two zeros and we will write the values of a, b and c. So your a is 4, b is minus 4 and c is 1. In order to find zeros, we have to factorize this. For that we need some steps. We'll follow some steps. So you have to multiply first term and the last term. That is 4 multiplied by 1. So your first term is 4 and the last term is 1. You always have to multiply the coefficients only. So we have got 4. Now this 4 we have to split it, or we have to write in such a way that its addition and subtraction should be equal to middle term, which is minus 4. Like we have to break down 4 in such a way that its addition and subtraction should be equal to minus 4. For that we will make factors of 4. So factors you all know, it's 2 by 2 and so 2 into 2 is 4. But are we getting minus 4 if I am adding 2 plus 2? If I am adding 2 plus 2, I am getting positive 4. But I need minus 4. So I will try minus 2 minus 2. Because I know minus and minus is addition with a sign of subtraction. So if I use minus 2 and minus 2, I am getting minus 4. So let's put the value of minus 4 over here. So I will write it as 4s square minus 2s, because I am splitting minus 4 into minus 2 and minus 2 plus 1. Now we have to take common. We will make two pairs and then we will take common. For taking common, let's do that thing again in rough part. I will break down this into more simpler form. See, 4 I can write as 2 into 2 and s square I can write s into s. Minus 2s. 2s is as it is because it cannot be broken down. So now see, here 2 is there, 2 is there. Common means the thing which is coming in both the factors. S is there, s is there. That means 2s we can take common since 2s is coming in both the numbers. 2s is coming here also and here also. So I will take 2s common and inside I am left with C. If I have taken this 2 out, this s out. So I am left with 2 and s. So inside also I am left with 2s. Now this minus I will write, as it is, and 2s. This complete 2s I have written outside. So if everything I have written outside, only 1 will be inside. Now this minus I will write as it is. This 2s plus 1, we cannot write it in more simpler form because nothing is common. If nothing is common, that means only 1 can be written outside. 1 is common, that means whenever we write minus outside, the inside sign will always get change. So I will write that thing first so that I won't forget it later. Now 1 I took out, inside same number will be there and same number, because if I am taking 1 outside, inside everything will remain same. Now see, these two should always be same. Now I will write this as, I will take this as common, and whatever I am left with, I will write here this 2s minus 1. So now I have got two factors. For finding zeros, compare these two factors with 0. Your 2s minus 1 equals to 0, and second 2s minus 1 will also equals to 0. Now just solve it. 2s, shift 1 to that side, so minus 1 will become plus 1. And as since this 2 is getting multiplied with s, this side it will get divided with 1. This, it will also be same because the number is same. When minus 1 we are shifting that side, it will become plus 1, and this 2 is getting multiplied, that means this side it will get divided. So we found two zeros. That means our alpha 1 by 2 and beta also 1 by 2. Now half of the sum has been done because two zeros we have found. Now let's verify the relationship. So you know, just now we have studied like alpha plus beta. Sum of zeros is minus b upon a. What is your alpha? 1 by 2. And what is your beta? Again 1 by 2. So what is b? B is minus 4. This minus will also come, and that number should also come full. A is 4. So let's solve this. 1 plus 1 by 2. This minus and minus will get cancelled, and 4 will also get cancelled. So here 1. So 2 by 2, again it will also get cancelled. So 1 equals to 1. That means left hand side equals to right hand side. Your first relationship is verified. Oh, yeah. Now product of zeros, that is alpha into beta. So product of zeros is C upon A. Your zeros were 1 by 2 into 1 by 2. C is 1, A is 4. Now 1 into 1, 1, 2 into 2, 4. So again 1 by 4 is equals to 1 by 4. That means left hand side equals to right hand side, and hence your zeros are verified for both addition and multiplication. Let's do third part of first question. So they have given you 6x square minus 3 minus 7x. First of all, you have to convert, or you have to write this equation, write this polynomial in standard form, like we have discussed. It should be always 6x square minus 7x minus 3. It should be in standard form, either in decreasing or increasing degree of a variable. Now we will write the values of a, b and c. A is 6, b is minus 7, and c is minus 3. Now we will do the same process. First we will multiply a with c. A with c, 6 into minus 3. So I got minus 18. Now minus 18 I have to write in such a way that its addition I will get, I have to break into two numbers so that so we have to make the factors of minus 18 and select two numbers so that the sum or subtraction of those two numbers will be equal to your middle term, that is minus 7. So let's make the factors. 2, 9, 3, 3, 3 and 1. So we can see 18 is 2 into 3 into 3 is 18. But we need only two numbers. So we will try. First we can multiply these two. So 2 into 9. So let's try. 2 plus 9 is 11. 2 minus 9. So we cannot take this. 2 minus 9. Minus plus is minus. So we get minus 7. Because the sign will always which is with the bigger number, and bigger number is 9. So 2 minus 9 will be equals to minus 7. That's what we need, minus 7. So we break minus 18 into minus 7 into 2 minus 9. 6x square. So minus 7, that is plus 2x, and minus 9x minus 3. Now we have to make two pairs and take out common. We will write this thing in simpler form. 6 is 2 into 3, x square is x into x, plus as it is 2x, 2 into x. So in both the terms 2 is coming and x is coming. So 2x we can take out common. Now what we are left with? Here x and 2 we have used, so 3 and x is left, plus here 2x full we have taken out, so only 1. So minus as it is. This also we will write in a simpler way. 9 is 3 into 3 into x. 3 we can write as it is. So we can see 3 is coming in both. So we will take 3 common. I told you if minus is out, the inside sign will get changed. So if minus is there, plus we will write. We will write before so that we will not forget it later. So what we are left with? 3x. Here 3 have taken out, so only 1. Now see, these two are same. We will write out 3. And the remaining things we will write as it is. 2x minus 3. Now to find zeros, we equate both equals to 0. Let's solve. 3x, this 1 we will shift to other side, and plus 1 will change into minus 1, and 3 is getting multiplied with x, therefore on changing the side it will get divided. So 0 will be equals to minus 1 by 3. Now let's find out the other one. Minus 3, if we shift to other side it will become plus 3, and 2 it will get divided on shifting to the other side. So other 0 will be 3 by 2. So 2 zeros we have found. So our alpha is minus 1 by 3 and beta is 3 by 2. Same thing we'll do to verify the zeros. First we will do sum of zeros. Alpha plus beta is equals to minus b upon a, where alpha is minus 1 by 3, beta is 3 by 2. B is minus 7, minus of minus 7, and a is 6. So we'll solve this. Taking LCM of 3 and 2, we will get 6, and here minus 2 plus 9, here 7 by 6, minus 2 plus 9, minus plus is minus, that means 9 minus 2 will be 7, and sign will always be the sign which is with the bigger number. With bigger number plus is there, that's why it will be positive 7 by 6, which is equals to 7 by 6. Hence the result for addition is verified. Now we have to verify the zeros with the product of zeros, that is alpha into beta is equals to C upon A. Your alpha is minus 3 or minus 1 by 3 into beta is 3 by 2. C is minus 3, A is 6. We'll multiply it, minus 1 into 3, minus 3, 3 into 2, 6. It is minus 3 by 6. We'll further simplify it, 3 1 is 3, 3 2 is 6, 3 1 is 3, 3 2 is 6. So it will be 1 by 2 equals to minus 1 by 2 equals to minus 1 by 2. That means your result for product is also verified. Hence we found the zeros and verified the zeros for addition and for product. Now we will solve fifth sum of question 1. It's t square minus 15. They have given it. It is little bit different from the remaining sums. So we will just convert it into simpler form. It is not in general form. General form was ax square plus bx plus c. So here you can see tx square minus 15. So this middle term they have not given. So you can see your a will be equals to 1 with 1 t square. B will be 0 and C will be minus 15. Now we will just write it in simpler way. So you know, if I write under root 15 into under root 15, that is the square of root 15. Square will always get cancelled with square root. So root 15 into root 15 will be equals to 15 itself. So this 15 I have written the square of root 15. The reason I have written it in this way because we know one formula, a square minus b square is equals to a minus b, a plus b. We have to factorize it so that we will be able to solve the zeros. So now we got the same thing. See, a square, your a will be equals to t square minus b square. B is root 15. So now we will write it in this way, a minus b, a plus b. That is t minus root 15 and t plus root 15. In last question also we got two factors and now again we got two factors. Now we can write it equals to 0 in order to find the 0. So t is equals to, if we shift root of minus 15 to other side, it will get plus of root 15 or root 15 you can say. Now writing this, t plus root 15 is equals to 0. So shifting plus t root 15 to other side, it will become minus of root 15. So two zeros we got, that is alpha is equals to root 15 and minus root 15. Now just verify the result. Product of zeros. That means alpha plus beta is equals to minus b upon a. Alpha is root 15, beta is minus root 15. So we can write plus minus of root 15. So your b is 0. 0 upon 1. 0 upon something will be equals to 0 only. So it will be plus minus will also be 0. 0 equals to 0. So sum of roots is verified. Left hand side equals to right hand side. Now let's verify the result for product. Alpha into beta is equals to c upon a. Alpha is root 15. Beta is minus of root 15. Your c is minus 15. So I told you earlier also, root of 15 into root of 15 will be equals to 15, but it has a one negative sign, so it will be minus of 15. Minus of 15 equals to minus of 15, hence verified. Question second of exercise 2.2. Now it's completely opposite to the first one. Earlier you had to find the zeros and verify the relationship. Now the zeros have been given to you and you have to find a polynomial. So it's very easy. We will use the same relationship. Now we will just write alpha is equals to root 2, beta is equals to 1 by 3, and alpha plus beta is equals to minus b upon a. Here you have been given sum and product of zeros, not zeros. So sum they have given and product they have given. That is alpha plus beta they have given root 2 and product alpha into beta 1 by 3. So we know alpha plus beta is equals to minus b by c. That is root 2 is equals to minus b by c. And now alpha into beta is equals to c by a. This is b by a. 1 by 3 is equals to c by a. So from this mark is 1 and this is second. So from second equation you can see your a is equals to 3. If you are getting such a situation in which in first equation you are getting 1 and in second you are getting 3. So just multiply the first one and divide with the same number. Here if I multiply and divide the equation 1 with 3, I will get minus b by a is equals to 3 root 2 and 3. So I got this mark equation 3. Now you can see your a equals to 3 and second also opposite to a you can see 3 is there. Now from here we can get the values. Your a is equals to 3, b is equals to, since minus is there I will write minus 3 root 2 and c is equals to 1. So I write the polynomial ax square plus bx plus c. I just put the values of a, b and c. A is 3, b is, since minus is there so I will write minus 3 root 2 x and c is 1. So this is your polynomial whose product of zeros and sum of zeros they have given. Now sum of zeros is alpha plus beta is 0. That means minus b upon c is 0. And product of zeros alpha into beta is c upon a. That is root 5. So we will write minus b upon c is equals to 0. We'll mark it equation 1, and c upon, this is b upon a. C upon a is root 5. This is 2. So this is very easy. So I'll just write over 1 here and 1, because if nothing is written, that means 1 is there. From here, from equations 1 and 2, I can conclude your a is equals to 1, b is equals to 0, and c is equals to root 5. So a general equation, ax square plus bx plus c. I will just put the values of a, b and c. Where a is 1, so it will be x square, b is 0, so I won't write anything, and c is root 5. So this is the polynomial for which sum of zeros and product of zeros have been given. Now there are 4 remaining parts of question number 2, and you can do those parts by yourself. And if you have any doubt, you can always post it in the comment section. Thank you so much for watching the video, and I hope to see you in my next one.